Hello, I'm Dr. Archana. Today we will learn about a very important class of compound, that is phenol. So please get your pen and paper and let's begin. I'm sharing my whiteboard. Phenol, as the name suggests, is actually hydroxy derivative of benzene. So phenol is actually obtained by replacing one of the H, that is H of the benzene ring by OH group. Hence, it is a hydroxy derivative of benzene. We can have a single OH group attached to the benzene ring, or we can have dihydroxy derivatives like catechol, which has one hydroxy group attached to benzene at position 1 and another hydroxy derivative attached to benzene ring at position 2. So catechol is actually benzene 1,2-diol. Similarly, resorcinol has one OH group attached at one position and another OH group attached at third position, that is meta position. So this is known as ortho position, this is known as meta position, and this is known as para position. So 1,3-diol, benzene 1,3-diol is nothing but resorcinol, another dihydroxy derivative. The third in the list is hydroquinone, which is 1,4-diol. That is, one OH group is at first position of the benzene ring and the second OH group is at the fourth position of the benzene ring. That is, para dihydroxyphenol is nothing but your hydroquinone or benzene 1,4-diol. So this was the general nomenclature about the various derivatives of benzene. Let's move on to the structure of benzene hydroxy derivative, that is phenol. So let's move on to the structure of phenol. Phenol, as we can see, has a benzene ring and it has a carbon atom to which OH group is attached. So this carbon oxygen bond is 136 picometer in phenol and the angle between carbon oxygen hydrogen is 109, that is less than the tetrahedral angle of 109.5. This is due to the two lone pairs present on the phenol. This value is low as compared to methanol because there are two reasons. One, the carbon in methanol is sp3 hybridized, whereas the carbon to which OH group is attached in phenol is sp2 hybridized. Also, the CO bond length is smaller for phenol. The reason being smaller because one, the carbon to which OH group is attached is sp2 hybridized. This is the first condition. Second, it has partial double bond character. So these are the two main reasons as to why the CO bond length in phenol is less as compared to alcohols. Let's move on to a very important segment, that is synthesis of phenols. So phenol was actually isolated in the 19th century from coal tar. However, today phenol is synthesized in laboratory. So there are various syntheses. We'll consider the most important 3 or 4 syntheses. So let's begin. The first synthesis will be from haloarine. As the name suggests, haloarine means halogen is attached to the aryl group. So we have the benzene ring to which chlorine is attached. To this chlorobenzene is when treated with NaOH, what we obtain is sodium phenoxide. Sodium phenoxide is then further treated with HCl to obtain phenol. This is the first synthesis of phenol. We can also obtain sodium phenoxide from benzene sulfonic acid as follows. So you have benzene sulfonic acid is when treated with NaOH at high temperature, we get sodium phenoxide. Over here also, this procedure happens at 623 Kelvin and at 300 atmosphere. So we have benzene sulfonic acid on treatment with NaOH, alkali, and heat, we get what is known as sodium phenoxide, which will undergo the same procedure of acid hydrolysis to give you phenol. We can also synthesize phenol from benzene diazonium salt. This is benzene diazonium salt. When this is treated with water or hydrolyzed, what we obtain is phenol. The next is a very, very important, commercially important synthesis of phenol. It happens that the starting material of this particular synthesis is cumene hydroperoxide. Cumene hydroperoxide is nothing but isopropyl benzene. So let's see this particular synthesis from cumene. So from cumene, first cumene hydroperoxide is obtained, and then on that on treatment will give you two commercially important or industrially important compounds, that is phenol as well as acetone, both of which are very much useful as a starting material for various products in industries. So let's begin. CH. This is nothing but your isopropyl group attached to benzene. This is what is known as, the general name is cumene. So this on air oxidation will give you so we can see the peroxide group is attached in this. This is nothing but your cumene hydroperoxide. Oxide. This on acid hydrolysis will give up two compounds. One is acetone plus phenol. So we can have a memory technique like this, that this bond will break, this OH memory tip will go and attach over here, and we end up with what is known as phenol, and we end up with what is known as acetone. Similarly, you can have memory technique in this also, where you can write water as HOH. So one HCl will go like this, N2 will get removed like this, and this OH will go and get attached to the benzene ring. So you have N2 gas will be liberated, and byproduct you have HCl. So these are commercially important compounds. So that was all regarding the synthesis of phenol.